Today I will start a new chapter, transport, the difference between first transportation and assignment. Then I'll work out the problem of how to work out the problem of transportation. This is a very common question. What are the differences between transportation and assignment? So assignment. So the first difference is that transportation is a type of transportation. We know transportation means we have the things we have to transport from one destination to another. So in transportation, the main objective is that we should minimize the cost of distributing a product from a number of sources to the number of destinations. So it is a special kind of and it is a special type of LPP, linear programming problem, where objective is to where objective is to minimize the cost the cost of distributing a product from a number of sources from a number of sources to a number of destinations. Assignment, this is transportation. Assignment means we have to allocate different jobs to different people so that the cost of assignment is minimum. It means allocating various jobs to various people in an organization in such a way that the overall processing time is less processing time is less, overall efficiency is maximum. Efficiency is maximum. Then there are now regarding the methods. Three methods are used for three methods are used for solving a transportation problem. Solving a transportation problem. First one is VAM, Vogel's approximation method. B is northwest corner method. C is your least cost method. And here it can be solved by Hungarian method. Solved by HUN, Hungarian method. Here there is no restriction. Here there is no no restrictions, many allocations, many allocations can be done, can be done in a particular row or particular column. However, in assignment problem, one allocation should be made in a particular row or in a column. Only one allocation can be made in a particular row or in a column. When total demand is not equal to, when total demand is not equal to total supply, it is known as unbalanced problem, transportation problem. When number of rows not equal to number of columns, unbalanced assignment problem. Assignment problem. When we work out the problem, all these definitions will be very much clear. So we have already told, I have already told you that there are three methods to solve a transportation problem. So first I'll work out with least cost method and northwest corner method. So let me start with the northwest corner method. First, if one problem, I'll be working by all the three methods and you will see the differences in answers. So first one is the northwest northwest corner method. I'm now dealing with only transportation part. First, let me finish the transportation part, then we will go for the assignment part. So suppose this is a problem given to you. So here D1, D2, D3, D3, D4, O1, O2, 6, 4. These are the cost. Inside is the cost 8, 9, 2, 7, 4, 3, 6, 2. And here it is demand is given. What is the demand? Demand 6, 10, 15, 4. And here last column here supply is given. This is the question given to us and it is 14, 16 and this is 5. We have to work out the northwest corner method. Northwest corner method, as from the name itself we know, here this is the northwest corner. Northwest corner. So we will start filling from at this end or at starting from this cell, whatever the value. So this is a process. So this is the northwest corner of entire cell. So here in the first case, demand is 6 and supply is 14. So we can this demand we can fulfill and it is smaller. 6 is smaller than 14. So we will write 6 here and we are fulfilling the demand. That means this column, and we'll make it a circle, and we will cut this column because it is because we have fulfilled the demand of this column completely. And here what we will do, we will subtract 6 from this 14, and this will be the supply remaining left. That means 14 minus 6, it will be 8 now. And as we have already crossed this column, so now this is our exist new cell, this one. So, and this one is the, that means D2O1 is the northwest corner of this new cell. So we will start allocating here. Here, out of supply is 8 and demand is 10. So 8 is smaller than 10. So we'll first fill up 8 here. 8 fill up here. That means 8, this has completely exhausted. And now we will cut this row this time. It has completely filled. And out of this 10, 10 minus 8, demand was 10 and supply was 8. So we are shortage of another 2 demand. 10 minus 8, so it is your 2 remaining. 2 demand remain unfilled. So now our new cell will be this one, and again this is the northwest corner, and again demand is 2 and supply is 16. As 2 is smaller than supply, we will fill 2 here, cut this 2 and cut this column here, will make circle, and here supply will remain 16 minus 2, it is 14. Now our this cell remains, this cell remains. So, and this is the next northwest corner. I will start always filling with this north corner. That's why its name is north corner. And demand is 15, supply is 14. 14 is smaller than 15. So write 15 here, 14 here, and make it a circle, and make it as it is 1. And this 14 will cut down this row. Then again we will cut this row again. Then again these two remains, it is 1 and 4, so we'll just fill 1 here, and here it is will be 4 here. So demand and supply we have fulfilled, and so here it is 0. So in this way it is a very simple one. You have to just only filling with the northwest corner. And now total cost is equal to, we can make allocations are made on this cell, this cell, this cell, this cell, this cell, and this cell. So it is equal to your 6 into 6 plus 4 into 8 plus 9 into 2, 9 into 2 plus 2 into 14 plus 6 into 1 plus 2 into 4. So this is the total cost. So it is 36 plus 32, 18, 28 plus 6 plus 8. It will be equal to 128. So cost is rupees 128 by our northwest corner method. Now, second method of solving. So this transportation problem is so easy. You can see northwest corner means you will only start filling with the northwest corner of the shell. Next method is least cost method. Least cost method of solving the transportation problem. Same problem I'll work out by least cost method. Least cost method. This method, before that let me write down the rule. This method consists in allocating as much as possible in the lowest cost cell and then further allocation is done, and then further allocation is done in the cell with second lowest cost, and so on. So this is the rule of least cost method. And if you see the definition of different of transportation, you can see that here there is no restriction. Many allocations can be done in a particular column or row. You can see that in this particular row, two allocations have been made. Here also two, here also two. So, but in case of transportation, only one allocation should be made in a particular row or a column. And here this is a balanced transportation problem, because if we see total supply in this problem is equal to total demand. When total demand is equal to total supply, then it is a balanced transportation problem. So it is a balanced transportation problem. So next I'll work out the same problem here by least cost method. So this is the same problem I've noted down. This is the demand, and this is the supply. So least cost cell, we will start allocating as much as possible to the least cost cell. So here you can see that out of this cost, the least cost is your one. So here one least cost cell means we will start allocating to this cell. Here 14 is the supply, 14 is the supply and 15 is the demand. So 14 is the supply and 15 is the demand. So what we will do? So what we will do first we will fill up 14 here, 14 here. So here it is, we will be allocating 14 here, and so here it will be if we subtract 14 from here, it will be, sorry, it will be 1. Here it will be 1. That means 15 minus 14, it will be 1. Now as we have completely supplied this for this row, so what we will do, so this 14 we can cut it down. We have cut this 14, and here in for this column D3 demand is now 1. Next we will go to the next most lowest cell. Here you can see this 2. After 1 rupees 1, it is the 2 is the lowest one. But we find 2 here also it is there, and for here also it is there. It is your, if it is O1, O2, O3. So there is, you can allocate to anywhere, it will be fine. So let's say I am choosing this 2. So I will allocate 1 here, and I will cut this one. Here again it will be, if you subtract 1, supply will be your 15, because demand was 1, supply remaining is 15. Next this 2, this 2, this 2, I will allocate 4, demand is 4, I will allocate 4 here. So here supply is 5, means it will be 5 minus 4, it will be 1 remaining. Next most lowest is your 3. It is very simple, it is 3. and supply is 1, demand is 10. 1 is lowest, so we'll first write down 1 here and cut this one, and here your demand will be 9. Next is the 4, these two out of these 4s. These two 4s are there, but we can see that 4 supply part we've already done it. There is no supply. And for this 4 also there is no supply. So we will exclude this 4. Remember this thing. We cannot allocate to this thing because supply column has already existed. We have supply only in this O2 row. So we will choose the smallest among this O2. O2 here supply is 6. Supply is 6. Out of 8 and 9, 8 is the smallest one, so we will first allocate this 6 here, and we'll cut this 6. Next most is the only one, that is the 9. That here we had we cannot have, we had 7 also. So this 4 we have already existed, so we cannot, you see this 4 have already existed here, so that's why I cannot allocate to out of this 7, 8 and 9. 7 was also the smallest one, but as it has no demand in this column, only we had demand in D1 and D2, that's why in between 8 and 9 we have to choose. So this existed, only remaining is your 9. So here 9 plus 6, so it remains your first, so it remains your 0. So initially after 6 it was 9, then after 9 it was again 0. So we have fulfilled the least cost method. It is very simple. And how many allocations are there? 1, 2, 3, 4, 5 and 6. And here also you can see how many allocations are there: 1, 2, 3, 4, 5, 6. See, if suppose there are rule is that if there are or in both the cases we have allocations 6, number of allocations number of allocations is equal to 6. Suppose number of rows is equal to, denoted by m. We have 3 rows and n number of columns. Number of columns are 4. If number of allocations is equal to number of allocations is equal to 3 plus m plus n minus 1, then it is equal to, if this is the case, then then the solution is feasible. So it is your 3 plus 4 minus 1 is equal to 6. So we have a solution is feasible, and we can see that here there is no closed loop is formed, so solution is non-degenerate and a feasible solution. So next we will determine the cost. Same thing, 1 into 14, 1 into 14, 1 into 14 plus 8 into 6 plus 9 into 9 plus 2 into 1 plus 3 into 1 plus 2 into 4. So it will be equal to around rupees 156. So you can see the same problem is solved by two different methods. They are giving two different answers. In northwest corner method it was 128, and in case of least cost method it is 156. Now we will start with working with the third method. Third method, that is Vogel's approximation method. Approximation method of solving the transportation problem, and it is known as, very commonly known as, WAM. So the same problem I'll work out by Vogel's method. So in both the cases we found that the solution is non-degenerate basic feasible solution, because number of allocations is if following the rule of m plus n minus 1, and all the allocation you can see all are independent. It is not forming a closed loop. We cannot return back to the original position. So all the allocations are independent. So that's why it is non-degenerate basic feasible solution. So the same problem I'll work out by worm. D1, D2, D3, D4. This is the demands. It is the supply. 6, 8, 4, 4, 9, 3, 1, 2, 6, 5, 7, 2, 14, 16, 5, demand 6, 10, 15, 4. So this is the question given to us. So this problem we will be working out by Vogel's approximation method. Before starting the Vogel's approximation method, let me write down the rules, what should be followed for Vogel's approximation method. First one, number 1, compute the difference between the smallest and next smallest in each row or column, in each row slash, not slash, it should be and, each row and column, and the difference is known as penalty. Highest difference between column or row is considered. If tie occurs, use any of your choice. Use any choice. Third rule is that identify least cost cell from highest penalty. Penalty is the difference from highest penalty for allocation. So these are the rules. So let me start with this. So for this problem, again I have to draw this table once. Six, 4, 1, 5, 8, 2, 7, 4, 3, 6, 2, 6, 10, 15, 4, 14, 16, 5. This is supply. This is D1, D2, D3, D4. Here it is O1, O2, O3, and here it is the demand. Okay, now we have to calculate the penalty. Penalty, let's say I'm computing the penalty for here penalty P1 for this row, here P1 for this row, and here this P1 for O3. Similarly, here also I'll compute the penalty for columns. 4 columns are there, so 1, 2, 3, 4. So first rule says that compute the difference between smallest and next smallest value. So here smallest is a 1 and next smallest is 4. So 4 minus 1 difference is 3. Similarly here for this row O2 row 2 is the smallest, next smallest is 7. So 7 minus 2 it is your 5. Then this is 2 and this is 3. 3 minus 2 it is your 1. Then again here penalty, P stands for penalty. Here for column wise if you see 4, next is smallest is your 6. 4 and 6 difference is your 2. And here 3 and 4 difference is 1. Here 1 and 2 difference is 1. Here 2 and 5 difference is 3. So rule says that we should choose the row or a column with highest penalty. Here highest penalty we are getting is 5. So we make a arrow here. Then where that means allocation should be made to this row. But where it should be given? It should be given to the least cost cell. So we have identified it will be row O2. Row O2 least cost cell is our 2. 2. So we will allocate here. We will allocate in this cell 2. What we will allocate? Demand is 15, supply 16. 15 is less than 16, so we will first allocate 15 here, make it in a circle, and we will cut this. And here remaining will be supply will be 1. So in this way, what we are doing, so entire row we will, so entire column, because the column has been existed, so entire column we will cut it, because row we are having 1, so we will cut it, we have cut down. So next same rule follows and we will again compute penalty 2. Penalty 2. Here also first row wise. Smallest one is 4. Next, ignore this one. So we have ignored this one means we will make a dash here. Here there won't be any calculation. 4 and next smallest is 5. So difference is 1. Likewise here 7 and 8 difference is 1. Then again 2 and 3 difference is 1. Likewise here 4 and 6 difference is 2. Here also it is 1, 3 and 4 1. Here dash 2 and 5 3. So again we see that the highest difference is highest penalty is our 3. So we will allocate to this D4 column. So let's see which is the lowest cost cell. It is 2. So we will allocate, and out of this demand is 4, supply is 5. So 4 is less, so we will write down 4 here. Make a circle, we'll cut it, so this column is completely exhausted. Completely exhausted. Here it will be 1. Completely 1. So here you got it. This one again, we have these two, the columns. That means these two D1, D2 shells are there. So now we'll again compute another penalty. Penalty will go for penalty 3. Yes, it is 3. Penalty 3. 3. So now again follow the rule. 6 minus 4, 6 minus 4, 2, 8 minus 1, 8, 9 minus 8, 1, 4 minus 3, 1, 2, 1, 1. Got it. Here also, here it will be same. These two will be dash, and here it is 1. So we are having 2. Here also 2 highest penalty, here also having highest penalty. Let's say I am choosing this 2. This 2. This 2 means we will be allocating to this row O1. What we will be, where we will be allocating to the least cost cell. So it will be our 4. So here we will be allocating. What we will be allocating? Demand is 10, supply is 14. Smaller is demand. So write 10, cut this, and here supply remaining will be 4, 10 minus 4, and you will cut this row, this column. So here here we have allocated. Next we will go for penalty 4. Compute penalty 4 here. Here nothing. All 3 columns have been exist. Only remaining is 6. So we will write down 6. Here also 8. Here 8. Here it is 4. Similarly here penalty. Let's say for this column wise, let's say do it. Here all these 3 will be dash. Here it will be 2. So out of this penalty, 4 penalties, this 8 is the maximum one. So we will do our allocation here, 8. So here supply is there 1 and demand is 6. So we will, 1 is smaller than 6, so we'll put it 1 here, and we will cut this supply part. And so this row again, this row existed, and here remaining will be 5. It is 5. So demand is 5. So next we will compute penalty fifth penalty P5 here, and here we will, as we have done this. So now this row is completely exhausted, this row. So we will make it dash here. This row we will exhaust it. This one exhausted completely. This one completely exhausted. So now here remaining only 6, and here it is only 4, and here again if we have to draw P5 for this problem. Here 3 dash were there, and here 2. 6 minus 4, it is 2. 2. So 6, it is the maximum one. So we will first allocate here 6. 6, that means this column here it will be our 4. Here it will be 4. We will cut this. So this entire column crashed, and remaining next is, so here it will be 1, and this one we will write down here. So we have allocated this one. So this completes our all allocations. If you make a clean table of all allocations, or no need, if you can see it, it is allocation, total cost, transportation cost. Transportation cost is equal to 6 into 4 plus 4 into 10, 4 into 10, here 8 into 1 plus 2 into 15, 2 into 2 into 15 plus 4 into 1 4 into 1 plus 2 into 4 is equal to, if you sum it up, it is rupees 114. So you can see that for all the three methods, different costs we are getting it, and for this problem by VAM's method we got the least cost 114. It was 128, 128, 156, and here 114. Here also the solution is non-degenerate basic feasible solution because number of allocations we are seeing it in the 6 cells, 1, 2, 3, 4, 5, 6, and m plus n, same thing, m plus n minus 1 is equal to 6. So we got the solution is non-degenerate basic physical feasible solution. So this completes our transportation problem, and it's very easy to work out.